Good morning. Am I audible?
Morning, sir.
I thank you very much for your response. Before we start the class, maybe let's discuss a few things. There's somebody who are asking for rescheduling tests. Two, frankly speaking, I don't have any venue to reschedule other than 16 Friday. But is that true that some of you have two tests at the same time running?
Sir, is it not possible for test 2 to be done next week? Because
Because this
we
week
have
is
a lot of
11.
tests this week.
Yeah, because this is week 11. Week 11, then I will gonna carry the test in week 12. Then I have to give you your coursework.
Oh, how about in 20? Not possible.
Tuesday 20 during
20
my
or
class
21?
time, because I got classes here. Wednesday
Oh,
I have classes, so that's why I will give you a portion of your coursework where exam one, exam two, exam one assignments and quizzes. Uh, then exam two will be delayed a bit if I make it 23.
yeah, that's okay, sir.
So everybody okay on 23?
I think most of us will be okay, but you
But
can.
yeah, please, if you have any issues, please you have to make it now. If you have guys any problem on 23, please you have to complain now. Don't delay to the due date. 23 same time. Maybe if Tuesday, Wednesday. Okay. Okay, so let's talk about the SSRT. I checked the SSRT. Only 10 people who have filled the SSRT. Please try to do so. This is a compulsory by UTP to for you to fill the SSRT. Try to do it as soon as possible. Let me start recording. Okay, so today we have a new material. Let me check recording. Yeah. Okay, it's in this. Okay, so we got a new material today, which is the gear, which is the last chapter of an MoM, and we were gonna learn all the types of the gears, and we will take a spark gear particularly under scope to check so a gear, yeah, please try to do the SSRT at your campus. It is really compulsory, so you have to fill. Very few of you have done so far, so please try to complete it. Now we will have an overview about the gears, their function, their types, and then we're gonna talk about a few terminology used for gear analysis, and then we will discuss a few kinematics of the gears. But spark gear particularly is the one is under the syllabus. The rest of the gears are just for your information. Okay, so only spark gears is under the syllabus where we used to do some assessment. Other type of gears is just like for your reference. Okay. We will gonna have at the end of the subject be able to identify the type of the gear. We will be we will gonna learn how to use the standard for selecting gear and how to calculate the basic analysis for the gear, the central distance, contact ratio, interface limit, and then we will gonna determine the kinematic property of the gears. Now gear has a function to transfer a motion and the angular motion into an angular motion. Now let's compare to it is transfer a motion between two shafts. It is angular motion, the input, the output will be an angular motion. So transfer the motion, angular motion between two shafts. Now let's compare between gear and cam. Cam, it will be transferring the angular motion on the cam to a linear motion on the follower. So that the difference between gear and cam. And for linkages, linkages is angular motion to angular or angular to linear or linear to angular, all that's possible. Now, the function in gear particularly, it is very useful mechanism for maximizing the speed or minimizing the speed by changing the diameter of these gears. When you change the diameter of the gears from bigger to smaller, then you are varying the angular speed, and then the torque also you are varying, and then you will be able to vary the power. So this is why it's very useful machine in car particularly, because your engine is providing only a constant speed, constant power all the time. However, what you have to do, you have to vary this power in order to get a faster low torque, or maybe slower but high torque if you are climbing mountains, trying to go on uneven road. So this is the way that we are using gear. Now comparing this to cam or linkages, they have no purpose to just to transfer the motion. Yes, can be magnified or minimized, but not as compared to gear. Okay. So gears are a disc with a teeth, not necessarily, it could be friction without teeth, but however, these gears are two discs engaged by a friction surface, can say. Okay, and then when one turn clockwise, the other will be turned counterclockwise. Gears could be, and the friction surface could be have tooth, so tooth will force the engage with the other part, or there is no tooth at all, but just maybe the friction friction between the two wheels will responsible to produce the force for the transfer between the two discs. Now those who have teeth, it's more expensive, but positive engagement, no slip. Those without teeth, they are cheaper, but sometimes they slip at high load. Now we got a few types of gear: bevel, helical, spar, worm, rack and pinion, depend on the configuration of the gears. Under bevel, there is a huge group, meter, high board, face, zero, spiral gear, all these can be considered as bevel. Now this is that three family of the gears. Spar is a two parallel shaft, let's say, two parallel shaft with a longitudinal teeth. Two parallel shaft with longitudinal teeth. Helical, two parallel shaft, same as spar, two parallel shaft, but the tooth are inclined. Tooth are inclined. So two parallel shaft, but tooth are inclined. Recurve pinion, one shaft, the other linear. So this is more or less like cam. It's like cam. One is angular motion, the other one will be linear motion. So this is what we call recurve pinion. Then we have a bevel gear. If you notice, bevel gear are a perpendicular shaft, not parallel shaft. These are parallel shafts. Now these are perpendicular shaft. Okay, they are perpendicular shaft, but the tooth are straight to the shaft, so they are bevel. If the perpendicular shaft start having an inclined tooth, we will call it meter, which is similar as helical meter gear. It is a perpendicular shaft, but the tooth also inclined. Now, if they are a cross shaft, these are not this parallel. Here is perpendicular. Now it is a cross, like intersecting the shaft. That we call it worm gear. Worm gear. Now worm gear, screw gear, they are used for very high power transfer. It got like a screw shape. The other one is got a tooth. So this one, when this screw is turned, the other one will be turning. It have only one way to transfer the motion from the screw to the gear. Reverse is not possible. All the gear is walking forward and backward, can reverse its motion, except the worm gear. Now screw gear is possible, but in certain speed. Internal gear, it is same as a spar, but the tooth, instead of outside, it could be helical also, but now you notice that the tooth are outside the shaft. It could be inside, so that will be internal gear. Let's take one by one. We were going to discuss one by one. Spar gear. Normally we call one R as driver, the other one as driven, and from the name it's clear that the driver, which is the one that connected to the motor, driven, the one that is at the source of the output motion. Okay, as I mentioned, it is parallel shaft, and the tooth are also parallel to the shaft. Okay, spar gear could be from a train of gears. This one will transfer to that one because they are both on the shaft. That one is responsible to reverse the motion, and then consequently. Okay, so this train is used to magnify the speed or minimize the speed. Helical gear, from the name, this image is used for metric gear, screw gear, but particularly this one, the helical one. I think this one is, this one, the helical. Helical gear here, it has a little bit inclined tooth. The shafts are parallel, but the tooth is a little bit got some parabola or some function inclined. It's not straight, flat. Okay, it's used to have this inclination in the tooth to smoothen the pressure between the two shafts engaged. Okay, helical could be, the tooth could be so inclined like a triangular. This is also for a certain application where the thrust is balanced. Now, looking to bevel gear, there's two types. One with straight tooth like spar. They are first perpendicular. The shafts are perpendicular. So spar and helical, the shafts are parallel. Now, it is perpendicular shaft, but if you notice here, the tooth are in straight. So this is the spar. Sorry, the bevel was straight. The one that was inclined, we call it meter gear. Okay, that is inclined tooth is like helical. Okay, but the shafts are still parallel. Okay, now worm gear is one like screw which is connected to the source of motor, the power. The other one is got tooth to engage with that screw. Okay, now notice if screw running clockwise or counterclockwise, the gear can run. Okay, so it can reverse the motion clockwise, counterclockwise, but the source of input cannot be reversed. So this one has to be an input, the worm. The gear has to be an output. If I now try to twist the gear, trying to push the worm back, it will be not possible because the worm will be blocking the teeth from moving. So worm has only one way to move. It can reverse the motion, but cannot reverse the action by changing the source of input to output. Okay. It used to provide very, very high torque, low speed. That's why you can see it is really low speed. Now, rack cam pinion is like cam. It is changing angular motion into a linear motion. And rack cam pinion is used normally to like a mechanisms for specific application to provide some small distance traveling for the rack. Like an example, in the steering mechanism in the car, steering, when you turn the wheel of the car, you are actually turning a gear and pushing the rack left or right, and then the rack will pushing the tire left or right. Okay. An internal gear, or what we call it sometimes annular or epicyclics, is a same as a spar, but the tooth, instead of heading outside, it will head inside. So this is also possible. And instead of having this feature, could be have so many features inside. So the internal gear can pack so many gear inside. That's why we call it epicyclic, similar to our. And then epicyclic is like a universal. And then we call it like this because it's look like having a sun, the one at the middle, we call it sun, and the other at the between the sun and the annular, it's called planet because they are turning around the sun. And then this is the epicyclic. Okay. So I think that's all for the types of the gears. Now let's talk about spar in particular. This is just an introductory. Now let's talk about spar terminology. Terminology more or less are same for all gears, but somehow certain gears they may have additional terminology than the others. So we're gonna talk about the pitch, the pressure, the interference, backlash, and then all these features. Now let's look to to remove this one. Okay, so these are the spark gear tooth features. Tooth has to be a perpendicular, parallel to the shaft. Okay. Tooth is a revolute, and it has a geometry somehow like a parabola extruded. So the depth, we call it face width. Okay. And the revolute has an upper side, we call it addendum. Lower side, we call it dedendum. Okay. And then this upper and lower is divided by the circular pitch. Okay, this is the engaging pitch between the two gears. And the base circle, same as the cam, we got a base circle. This is, we call it dedendum circle. Dedendum circle. Okay. Now, in cam, the base circle is the most important, where we reference. In gear, the pitch circle is the one that more important and is responsible for getting, is responsible for all the calculation, the pitch circle. Okay. Now, pitch circle is the one that divided the addendum and dedendum into half, and that pitch circle is a measure to compare between the gears. Pitch circle is equal in imperial by d per number of teeth in the gear by diameter of the gear per number of the teeth. So diametral pitch could be circular pitch changed to a diametral pitch, because the standard is running by diametral pitch, but circular pitch is the one more theoretical one. Okay, is diametral pitch equal number of teeth per diameter. It's just like the pi embedded in the p. Okay, so number of teeth per diameter. So this formula is the most important in selecting gear. Let's look at, okay. Let's look to the diametral pitch. Diametral pitch is a number will be used to standardize the gear according to American Gear Manufacturing Association. This is the one that adopted in Malaysia. So we have to teach, for particularly this subject, we have to teach an imperial unit by inch. Okay, there is only two subjects in mechanic. You're gonna be facing an imperial unit, MoM, and air conditioning later on. If you, yeah. So the pitch circle is running by this number. We were gonna talk about this number later on, but just to keep in your mind, a smaller is the more coarse, the more big gear. A bigger is the more fine gear. Okay, the bigger number is the most fine pitch, and of course it will be fine gear. So the greater number of PD represent a smaller gear tooth. A greater number of PD, 200, it is a really small gear tooth. A bigger number of BD will be a really big gear. Okay, like an example, 48, it is teeny tooth, while 3 is really big tooth. Okay, now let's look to the module. This one is SI technique. That one, the imperial, which is where we used to use in assessment. Now SI we don't use in assessment, but just for your information, module is D over the N. Now it is just like same as the diametral pitch, but just multiplied by 25.4, which is the transformation of inch into centimeter. So that's all. So SI has no any difficulties is just changing the imperial to SI. And then the equation is reversed. That was N over D, here is D over N. Okay. Now looking to the force analysis in the gear. There is something we call it pressure line. Now you remember in cam we have a pressure line, which is the one that between the center of the cam and the center of the roller, or the center of the follower, contact surface. So the distance between the centers, that will be the pressure line in the cam. But here the pressure line is the one that touching gently the base circle of the gear and the base circle of the other gear. Okay, just line tangent between the two base circles. So that line is called the pressure angle. Now you can see the line is blue here, and there is an arrow traveling. This line is actually where the contact is happening at the dot between these two arrows. So once the tooth are engaged, the contact happen, and then it will be travel along to this pressure line. So this is the pressure line. These pressure lines can be different depending on the involute shape. If the tooth too sharp, then it will be for high pressure, but will have an undesirable radial load because the pressure is too high. There will be some additional, the pressure will be resolved into X and Y component, and then the X component will be a little bit more, causing undesirable radial load. And then possibility of interference, I mean, it's like stuck, the tooth are stuck. So it is very, very high possibility. Now, if we a little bit just try to float, what we call fleet the teeth, just fleet the teeth, making the radius of the fleet is bit bigger, the pressure angle will be 20. Now this one 14.5, this 20 degree, and at 20 degree it will be reasonable, moderate for all all the scenarios for pressure or radial load or interference. So it will be just moderate. If we keep smoothing the gear, smoothing in terms making too smooth, that will be result in lower pressure, but a greater for undesirable load and lower for interference. Okay, so it's depend. That means if you smoothen your gear, you will lose pressure in transfer between the two gears, and then you will may have more undesired loads, but less interference where the gear are jammed. Okay, so it's depend, you work the possibility between these three scenarios. Now let's see the involute tooth pressure angle, how it affect. Now we call 14, 20, and 30, 25. Now this is just a 10, 20, 30. So you can see for 10 is the involute a little bit sharp. For 20 is a little bit 10 fleeted, but for 30 is somehow like triangular, start to be close to triangular shape. If you notice at 30, there is only 2 points, 1 point appear for engagement. However, for 20, there is always 2 points of engagement. So that means when you increase the pressure, you will have more teeth to engage together. So you can see here, there will be more teeth for engagement. Here, there is only one teeth are engaged. Here is 2, here is 3 teeth. Okay. Okay, so you can calculate the diameter brush out of the diameter times cosine the pressure angle if you want to calculate. The third fine is called the pressure angle. Okay. Gear mating. The distance between the center of the gears, if becomes shorter, there will be a what we call jam between the tooth of the gear. If they become larger than the design, there will be a backlash. So to avoid that, we have to mating the gear perfectly. Mating the gear by making the pressure angle exactly right according to what we have. So you have to make the line tangent to the two base circle, making exactly the same value of the pressure angle. Okay. So the line, the one that may be here, just let me, the one that here, sorry, I mean, this is this line. It's difficult to do by mouse. This line, all this line has to be tangent a little bit to the base circle here. So this is a base circle of the other gear. So there have to be a tangent. Tangent mean is perpendicular on the radius and also tangent from this side. Now, mating gear is not like same as meshing gear. Meshing gear is different. You can mesh the 3 or 4 or 5 gears together, trying to create a train of the gear. The central the distance between the center of the gear, this is very important formula, is the second important formula. Just now we learned that the BD is equal no N over D. Now the other one is the center between the two gear is equal the diameter of the two gears, average of the diameter of the two gears per 2. Okay, so you add the two diameter divided by 2, or you just calculate the radius R1 and R2 plus together, you just add them. So this is the distance between the center of the gears. Contact ratio. Contact ratio is how many gears, how many tooth are engaged at once. So now here there is only one tooth are engaged. When you can see the spot, red spot, is only one tooth engaged. But here we got two tooth are engaged. One the contact here. One the contact here. The other one is contact here. So that will have higher contact ratio. Here we can see contact, second contact, third contact, fourth contact. So we have more tooth in contact engaged. When you get your gear in a smaller diametral pitch number, there will be more fine tooth and contact ratio will be more as well. Interference. Interference when you engage the gears and still there is a clearance between the tooth. These are called interference, and interference are sometimes good for lubricant, sometimes is not good. So you have to work the interference according to the design requirement for the whole system. Okay. To avoid interference between the gears, you have to follow exactly the standard line. We're choosing the teeth of the pinion and the teeth of the gear to be within the limit. Normally, the one that is responsible for interference is when you have a lower number of teeth, lower than 13 or 12, like an example. That will cause interference because the circumferences of the gear have to divide it by 13 segment, and that will cause interference. We will practically practice that later on. Maybe just to give you an example, the standard is to choose a specific number of the teeth for the gear. These teeth is the only available commercially in the market. So below 13, if you choose them, there will be an tendency for getting an interference. For the specific pressure angle, each pressure angle have different table. Okay. Of course, if the pinion, now I didn't mention what's the pinion, what's the gear so far. Maybe I will. Pinion is the one that we call it driver. Just now I call it driver gear, driven. One driver, one driven. The driver is connected to motor, the driven connected to the what we call it to the output source. So the driver here is called pinion also. So pinion, if 18 teeth, you can have an infinity number of teeth to be engaged with. To avoid interference, we can sometimes do a cut, undercutting the tooth. Sometimes it can cause a trouble weakening the tooth because it's reducing the root width, and that may be subjecting the tooth into severe bending later on here. But it also smoothing the motion between the two gears where have to be in interference, no choice. It have to be in interference. There we may just use a little bit undercut. Backlash. Now, backlash is things that when the two gears are loosey a bit, that can be happen when the central distance is a little bit apart, or the design of the two gears make the driven is a little bit smaller revolute than the driver. That may be a little bit different in the pressure angle by just a few degree, 1 degree or 2 degree. Okay, like say this is 20, this is 21, or maybe just a cause of manufacturing issues. Sometimes it's happening shrinkage in the manufacturing. Okay, so this backlash actually sometimes is good, sometimes is bad. It's good to allow for lubricant. It's bad because it causes vibration. Or uneven thermal. It's good to allow for lubrication and uneven thermal expansion, because these gears have to be expanded. When expanded, they will be jam. The tooth are jamming. So to avoid jamming, then we may have a little bit backlash to allow for thermal expansion. But sometimes are not good. When the backlash exceeds some range, they may cause a vibration. Normally, backlash in general is an imperfection of manufacturing. Backlash normally have to be within these two values. The backlash range has to be between 0.1 per BD to 0.05 per BD for American gear. Now for like more commercially, if you say in the market, they allow backlash between 0.5 BD to 0.3 BD. Now let's talk about the gear kinematic. So this is the kinematic of the gears, velocity between the pinion Pinion is the smaller one and the driver. Gear is the bigger one where it's driven. Okay. The gear A, the ratio, the velocity ratio between A and B, it will be the W of driver over the W of driven. Okay. Input, output, driver, driven, pinion, gear. This terminology may change, but the things are same. All are same. So driver should be the numerator. Numerators will be the derivative. And could be input, output. Okay. Bear this ratio equal to the will be in indirect proportional to the number of the teeth. So the ratio of the input per output will be in indirect proportional with number of teeth. Okay. I mean inverse proportional with the number of teeth. Okay, inverse proportional to the number of teeth. And of course, consequently, it's inverse proportional to the distance, the diameter of the gears, and consequently inverse proportional to the angles between the gears. Now, pitch line velocity, this is the angular velocity. If I want to convert it into linear, just multiply by W by R radius, then you will get the linear velocity. So let's have an example. A set of gear is used to reduce the speed from an electrical motor to shaft driving a grocery checkout. So this is the grocery checkout, the belt where you put the things that you purchase. So the motor here has to reduce its speed to that particular gear. So here goes the pinion input. Here is the gear, the output. The gear on the shaft, on the motor shaft, is 10 pitch. Pinion has 15 teeth and it drives at 1000 RPM clockwise. Determine the speed of the mating gears that has 45 teeth. Also calculate the pitch line velocity. Now we got the input speed and the number of teeth. And we have the output number of the teeth. By making ratio between the input and the output number of teeth, we will gonna find the velocity ratio. Velocity ratio is the inverse proportional with the teeth number, direct proportional with the speed. By getting the velocity ratio, we can extract the speed of the gear. And then linear velocity, pitch line velocity, which is the linear velocity, is just like multiply the number of teeth by the diameter. This is the diameter if given. Diameter of pitch is given. Diameter of pitch is given. Okay, so gear speed can be defined. Then you can find the by the ratio of the tooth. Then you can get the speed. And for pitch line diameter is first you have to extract the diameter out of the pitch diameter because the number of teeth here is 15 given, 45 is given. So you can substitute number of teeth, then you can get of the pitch diameter, then you can get the diameter, and then you just multiply angular speed by radius, you will get the linear velocity. As simple like this. Okay, let's see some more examples. A two gear are to be mounted in a 5-inch apart and have a velocity ratio of 4:1. Find appropriate pitch, diametral pitch, and number of teeth on both of the gear that will be suitable, assuming a 20 gear are used in compactness is desired and the gear with minimum number of teeth is being chosen. So we got the question says the gears have to be 5 inch apart. So the C between the two gear is 5 inch. This is what we call a C. The D over gear 1, the diameter of gear 2, diameter of gear 1, diameter plus gear 2 per 2. So this is the C, 5 inch. And then we have the gear ratio 4:1. That's now the velocity ratio. Okay, the gear ratio or velocity ratio. How to find, and the gears have to be 20 degree. So how to choose two gears for that particular purpose? First, what we have to reference to the standard of the avoiding interference. And we have to select a teeth number and check. If I choose 13 for pinion, the gear will be 13 times 4. So I have to check if it is bigger than the interference or less than the interference. Let's try one by one perhaps. If I choose pinion to be 16, 16 times 4 will be 64. 16 times 4 will be 64. So 64 is less than 101. So that's being it be possible for using for this application. It is avoiding interference. If let's say if this is 13, 13 times 4 will be 52 something. So 52 is bigger than 16, so that it is not possible because the maximum number of gear teeth has to be 16. If you choose 13 for pinion, the gear has to be 16 teeth. Let me repeat again. If we select 13 teeth for pinion, gears has to be 16 maximum. Now I have to maintain the velocity ratio. 16 times 4, 13 times 4, it is 52. And then that is bigger than the 16. So I cannot use 30. Maybe I check 14 times 4. If it is bigger than 26, if it is smaller than 26, then we can use, because this is the maximum allowed for the gear. So we can try number until we reach the one that is suitable. Now 16 is suitable because 16 times 4 is 64. 64 is less than the maximum allowed for gear. So we can use that gear for our application. Now the challenge is these gears, if I choose number of teeth 16, the other one is 64, that means I have to check the diameter if it can fit in 5 inch apart. So pitch diameter equal number of teeth per diameters, and consequently the ratio last ratio is the ratio between the teeth also, the gear diameter, so that we can find an equation, two equations that we can substitute in D2 in terms of D1. And D1 has to be 2 inch because we have to stick these two gears in. We have to stick these two gears or to mount these two gears in a 5 inch apart. So that will be the one 2 inch, the other one is 8 inch. Okay. So assembly as like this, we choose the gears from the table, from the standard. Okay. So the spark gear selection is depend on the diametral pitch, the pressure angle, and the number of teeth and the power transmitted. Now there is an additional to that. The diametral pitch, the one that the value inside the table here, is can be selected also according to the horsepower required to be drive and the speed. If let's say you want to get to transfer a power of 10 horsepower from one gear to another gear, so the speed you want to run at 900 RPM, so the diametral pitch has to be 6. It has to be 6 in order to transfer 10 horsepower at 900 RPM. Okay. Now diametral pitch, under each diametral pitch, there is a few teeth available commercially in the market. So when you choose, like an example, just now we choose 6 for 10 horsepower at 900 RPM. If I choose 6, I have to check. Under 6, there is only this available teeth in the market. Because in the market, there's an infinity number of gear can be manufactured. But in market, manufacturing only specific sizes and dimension, exactly same as the screw. Screw and bolt screw are running by a specific dimension. There is 4 mm, 8 mm, 6 mm, 12 and 14. This thing, this in the schedule number. Pipeline in a schedule number. There will be an infinity possibility of manufacturing these mechanical elements, but so we are following a standard. That standard is just to reduce the effort of manufacturing and then get a narrow power to be covered. Like an example, for 6 is covering 10 horsepower and 900 RPM. So you can use these teeth, the one that are available commercially. Just now, when we done this example, when we say we choose 16 teeth and 64, we have to check 16, yes, it is available in the commercial in the market, but 64 is not available here. So that we have to find another number. So we need to jump to 17 and then multiply it by 4 and then so on. Maybe I can have an example here. A pair of 20 pressure angle mild steel gear are to be selected for an application where they need to transfer 5 horsepower, the pinion drive at 1800 RPM. The ratio is 4. Determine the appropriate set of the gear for this application. So we got 20 degree, 5 horsepower and 1008 RPM. Now I think we have to go to the power table. 5 hours to be how much? 5 and 1800 RPM. So under 5, I check where is this is the 1800 RPM. So we have to choose gears out of BD12, the pitch diametral 12. Now let's look to the 12 pitch diametral. If pitch diametral 12, so that means if I gonna choose 13, my ratio, by the way, my ratio has to be 4. Gear ratio has to be 4. So if I choose 13, that will be bigger than the maximum. 14 times 4, bigger than the maximum. 15 times 4, still bigger than the maximum. 16 is the one, the first making smaller than the maximum, so what can be used. So 16 times 4 is 64. But now our PD is 12. Let's check. In under 12, this is the teeth that are available commercially. 16 is available commercially, but 64, there is no 64, there is 66. So 16, 64 not available, so we have to change, we have to propose another one. Perhaps let's check 18 times 4, which is the velocity ratio, That will be how much? 72. 72, yes, it is available. So both 18 and 72, both are available commercially. 72, by the way, if I choose 18, infinity number of teeth are still working very well. So 72 is can be used and avoiding interference, and both are available commercially. So this is the way that we select gears and according to the standard. So the procedure is simply like this. First, you get the power and the speed, intersect on the table, and then find appropriate BD. Okay. If you, let's say your power was not 1800, it's 1600 RPM. So you have two choices of BD, either 12 or 10. In that sense, if you choose 10, you will stress your system to run higher than its design. Yeah, if you choose 10, you will trying to select gear are supposed to work in lower speed. So that is a little bit stressing for the mechanism. But if you choose 12, it is a little bit like over expenditure to get more expensive than the requirement, but can operate with high safety factor. Okay, so you have to work the possibility if your speed running between two things. So once you choose the PD, you have to go and check by the ratio. If you choose 16, 30, 40, how much the minimum, the one that under the maximum can be used for this pinion and gear. And then you have to check if they are commercially available or not. If not, then you have to move forward finding a new set of gears and keep trying until you get the desirable number of teeth. Once you find diametral pitch is given, then you can get the diameters of these gears. The diameter of the pinion, this is not diameter of pitch, diameter of pinion, diameter of gear. Okay. Any concern? This is the only tricky part in the gear. Any concern so far?
No, sir.
Okay. So maybe we can continue having some more example. No, let's continue on meshing of the gear. If we mesh a gear, the gear train, how is possible to be do the analysis? Now, in the gear train, when we have several pairs are combined to reduce a high speed or to maximize the speed, it depends. So the things that we have, when we have multiple gears, we have to find the train value. Just now we learned gear ratio, when just two pair. If multiple pairs, they will have a train value. Okay, the train value of the gears. Now the velocity ratio, let's just to, this is the one that we learned from the previous material. Velocity ratio is the ratio of the driven over the driver over driven and inverse proportional to the number of teeth. And linear velocity, angular speed, time radius. And diameter of pitch is the number of teeth per diameter. Now the train value is more or less same as the velocity ratio. It is the driver over the driven. But the driver now is the one that the input source. The driven is the last one, not the second one, the bare one, the last one. So this is what we call a train value. When we have multiple gears are engaged together and trying to transfer the motion. Okay. Now notice here, when 2 engage with the 3, there is a velocity ratio because this is driver, this is driven. Now 3 and 4 is actually 2 gear on the same shaft. You can see here 3 and 4. They are both on the same shaft. So this is only one speed, the same angular speed. The same angular speed in 3 are same as 4 because they are connected to the same shaft. Now let's look 4 and 5. There is a change ratio, so there is velocity ratio. But 5, it is transferred directly to 6. Sorry, it's not transfer. It's just like the same wheel with the 6. So both are on the same speed. 6 with 7 has a velocity ratio because there is a transformation. So we have this velocity ratio 1, second velocity ratio here, and the third velocity ratio here. So the train value will be the multiplication of all these velocity ratios. Like an example, if let's say if this is the example, this is supposed to be an example. If 2 have number of teeth 12 and diameter pitch 12, 3 is only diameter given, and 4 is number of teeth given, and 5 diameter and diameter pitch, 6 there's a small information given for each particular gear. So you have to work out. First, we have to find the diameter of the gear 2. So number of pitch per number of teeth per diameter of pitch. Then you will get the diameter, and then you can find the velocity ratio between 2 and 3 by dividing either the number of teeth or the diameter, because the 3 got only diameter, so you can divide the diameters. So this is the velocity ratio between 2 and 3. Now let's see how to find the velocity ratio between 4 and 5. 4 got number of teeth, 5 have diameter and diametral pitch. So maybe diametral pitch equal number of teeth per diameter. So we can get the number of teeth at 5, and then we can find the ratio between N5 and N4. So D4 first, you try to find the number of teeth. Up to you, you can use the number of teeth or the diameter for getting the ratio. So the velocity ratio between the 4 and 5, and then the velocity ratio between 6 and 7. Okay, once you find all these velocity ratio, the train value will be the multiplication of these velocity ratio. 2.5 times 2 times 2.67. Just multiply. Now, why do we put this angle, the sign, sorry, the sign which is minus, is to give, to show us the direction of the motion. Let's say, if you just multiply by just all the way, you use sign all the way. So 3 signs will result in minus, and that means it is reverse direction. If this is turned clockwise, that will be 7 counterclockwise. And you can try it. If this is clockwise, 3 will be counterclockwise, because well, there will be in fraction and the linear velocity like this, so that will be counterclockwise. 4 also same as a 3, counterclockwise. If this is counterclockwise, 5 will be clockwise. Okay, let me just again, if this is 10 clockwise, that will be 10 counterclockwise. And 4 is same as 3, they both are the same shape, so counterclockwise. Sorry, if this is clockwise, that will be so yeah, if this is the clockwise, this is the counterclockwise. Okay, then that will be a reverse motion. So if that one, just maybe to give you if the arrow, if this is clockwise, that will be counterclockwise. Okay, that will be counterclockwise. If that one counterclockwise 4, then 5 has to be, if this is counterclockwise, that means it's continue like this. So that will be a clockwise in that sense. And 6 will gonna turn also clockwise because they are both on the same shift. Now, if this one clockwise, that will be, if this is the clockwise, then 7 will be also will be counterclockwise, and that's why the motion are reversed. You see, this one turn clockwise, the result will be counterclockwise. So normally, if the train is so big, just try to put minus for the all velocity ratios, and then if the train values odd number of train values, odd number of beers, like we got 1 beer here, 2 beer here, 3 beer here, 3 beers is an odd number, that will result in a minus value, so the reverse direction. If an even number of beers, that will be maintain same direction but magnify or minimize. So this is the way that we do for getting the train values. Sometimes we have an idler gear. Idler gear is a gear has no purpose other than just to reverse motion. So this gear has no purpose other than reversing motion. Like an example, this is clockwise. Okay, if we don't have the 3, we have the 4 directly engage with 2. Now you see 3 and 4 both same diameter, same size. So 3 has no any variance to 4. So we can just ignore 3 and put 4 here. So if we do so, the 4 will be counterclockwise. But if we want 4 to be in reverse motion, that means we have to have the idler, because the idler will have to be a reversing motion that will be turning counterclockwise, and then when it is counterclockwise, it will force the 4 to reverse its motion to be a clockwise, same as 2. So this is what we use for idler. Okay, there is a few examples here. Like an example, we give number of teeth, and then you have to find the train value. Now, in order to find the train value, you can just divide 28 by 42. This is the first pair, so you can get the train value here. The train value between G and F, so 42 divided by 27, 27 is for F. Then you will get the train value on this side. Then the train value between F and E, F the bigger disk, 38, and E, which is the 40 teeth. So you just divide, then you will get the train value at E. So these train values, there's 3 beers, 1, this one is 1, this one is second, and that one is the third beer, engage. So 3 beer engage, then just multiply the train value by 3. These 3 values, just multiply them. GH, FG, EF. Okay. And yeah, Maybe this is just for you for practice. Maybe I have a better in tutorials. I can get in tutorials here. The tutorials, or perhaps we can this one, the tutorial one. Yeah, we can. Sorry, let me check. Okay, we were gonna talk about these trends in tutorials, perhaps. I think I will stop to here, and then we will gonna have some examples during the tutorials. I got these examples to practice in the tutorial today. Okay. So you can see here such an examples where we use to ask for a question for exam 2. For exam 2, we have to have a cam and gear together. Okay, cam and gear together, not cam and linkages. Cam and linkages and gear will be all at the final exam. But in exam 2, we normally ask only on cam and gear. So this is the previous question during the exam 1, exam 2 for the previous semesters. We got this one, we got another one where you have to design the gear mechanisms to operate a cam, and the roller follower have to transfer the motion to a dial indicator or perhaps yeah, force indicator that will go a sliding block and spring force. Okay, so we're going to talk about this tutorial in the tutorial time. So maybe I can meet you in later on this afternoon to during the tutorial time. So far, any concern about the train value and the gear?
All clear, sir.
Okay.
So sir, for the exam 2, it will be about the gear and cam.
Sure, definitely. Gear and cam. Gear and cam, yeah. Only gear and cam, okay? I know linkages, you really, perhaps you hate linkages because it's a little bit lengthier procedure. Cam is much faster and gear is the simplest one. So we were gonna have a gear and cam only, and perhaps let us discuss the time of the, let me stop recording. How about if I propose a test time to be Wednesday afternoon? Because
Wednesday next week.
yeah, Wednesday next week.
Wednesday next week we have class from 12 to 2, and then I think most of the ME student are free after that.
But I don't have to do an assessment Wednesday. Sorry, I think it is not allowed by lecturer. Yeah, by the regulation of UTP. Wednesday is a free assessment day at the afternoon. So there's no choice other than using 23. Okay. Or maybe Thursday. Thursday?
Thursday, I think some of us have class on the evening.
Okay. So Friday next week, same time.
Okay, 12 to 6.
12 to 6, okay. And right. Okay, so please don't forget, do the SSRT because only few people have done the SSRT. Please try to complete this assessment. It is a must by UTP, okay? And thank you, meet you soon in afternoon. Bye-bye.
Thank you, sir.
Thank you, sir.
Bye.